Well, hello. Thank you for everyone that's here. Yeah, so this is going to be a presentation about gameplay programming, as you probably already know, um, but I'll just jump into it. Uh, so in 2024, I made my first game, Bloodelic. It was a turn-based strategy stealth game where you played as a little goo monster that could walk around walls and was trying to like stealthily kill everyone in the level. I worked on it for about 2 months, setting up a custom grid tool and basic movement for the character, and brought on a few people for in college for Georgia Tech's Fiji Dev, and that development took place over the course of about 3 months. I was super confident that it was going to be amazing. All the features was going to be in. It was going to be great. And it is a buggy, barely playable mess. This is probably the best example, or this is the video that I have on it. But notice how curated everything is, and it still looks kind of jank. Um, it took so much work just to get to this point, and there were countless bugs that were found. Not to mention, if you went one step forward, it would soft lock the game. There wasn't any in state. There was no way to win. It didn't properly keep track of people. The vision system didn't really work. Most of the features that were planned for it ended up getting cut. It was just kind of a mess. Now, the blame falls entirely on me for this. There was so much work going to work on, and it felt like the work just kept growing the more that I worked on it, and the more I realized what systems were going to be needed in order to make things work. So the biggest lesson that I learned from this was asking the question, what does it take to make a game playable? Not good, not polished, playable. So, like I said, for the writing up the announcement for it, this is curated for people who are making their first game from scratch, students and newcomers to gameplay programming that may have worked on a few games before, and board veterans that kind of want to just hear me yap. So, who am I? I'm Jade. I'm a gameplay programmer. I'm currently a mid-level client engineer working on Minecraft education. I'm formerly a gameplay programmer at Insomniac, where I was an intern in 2024 and 2025. I was a contractor, associate role. For a few months before fortunately ran out, and I graduated in 2025. So, going back to the question of what does it take to make a game playable? There's two different directions that this goes down. How much code does it take, and how much time does it take? Now, how much time something takes is nebulous, and I'll get into that answer, but it's a little bit easier to determine how much code something is going to take, and that is what we are going to be addressing. I'm going to use the metaphor of building a bridge. There's you, there's the gameplay, and then there's the chasm in between. Every game has a chasm between you and the gameplay experience you're intending. Your individual goal is to have a sturdy enough bridge to get between you and your game that stands up to winds, cars driving over it, and people doing the dumbest stuff in order to try to break it. But right now, you just need to get to the other side. Some games require much more work than others to get to the other side, larger gaps, unsteady ground, areas that to cross that require far more work than originally believed, but I'm getting a little too deep into this metaphor. Your first step is to try to understand just outline the required gameplay systems that you need in order to implement everything. Not from a high-level design perspective, but from a deeper programmatic understanding of what it takes to translate that design. AKA, what does it take for the computer to give you the gameplay that you want? Mini games require the same kinds of systems, so it's good to kind of go over some of the basics of what you're going to be frequently running into and some of the stuff to look out for. So I'm going to be going over 3 different kinds of games as a basis to build up the kinds of systems in order of complexity at least from my personal experience. Now, warning before diving in, we are ignoring all other disciplines right now, the work they put in. Some of these games require immense amounts of art, design, musical work, just some of the production alone. Uh, all other disciplines put in a large amount of work. We are ignoring them, and I apologize in advance. Additionally, this does not apply to every single game or even the ones within the same genre of games that I'm referencing. Every game has its own individual challenges. Some of them will be easier, some of them will be harder, some of them will break some of the conventions that I'm going to be talking about, and other complications that happen behind the scenes. So keep that in mind. And additionally, this is not to say that one is always easier than the other or that one is even like inherently better due to mechanical complexity. There are some games that are very, very easy to comparatively in terms of just generalization easier to make than others, but some games have far more amounts of polish and complexity that has been put in, and then some are just doing like a simple tech demo or just sort of like playing around with mechanics. So getting into it, I'm starting with 2D platformers. The beauty about a platformer is the centerpiece of your game is also the main thing that you need to worry about. I'm going to give the example of Celeste, and that's just sort of going to be the screenshots and GIFs that I am going to be using throughout. The main thing with the 3D platformer is you need to focus on the 3 C's. The 3 C's are camera, controls, and character. They're kind of lumped together because they all interplay off of each other. Some AAA studios will hire gameplay programmers specifically to code the 3 C's. Like I've seen job applications directly for this. It is a monster all in itself, but breaking it down, what exactly I mean. The camera is the viewport into the game world. You are controlling where it's located, how it's controlled, and importantly, rules around how it looks and is bound. For example, if you have a 3D or a third-person game, you need to make sure that the camera doesn't clip through walls. You need to make sure that it's able to rotate around the character, that it's able to push in and out. Etc. For controls, it is how the player interacts with the game, the mapping and abstracting of actions in the game to button presses and holds. The reason I say that explicitly of the abstracting of actions, of gameplay actions to player input is because this is going to be very, very important as we continue onwards of stuff that seems simple all of a sudden becoming very difficult based on its controls. And then finally, the character. This is kind of the broadest category. Really, everything the character does and the player that the player can control. This includes like combat and movement and traversal. This is an incredibly broad category that has so many different things attached to it. General player abilities. It's just you can go so many different ways with this. But in the view of a 3D or a 2D platformer, it's specifically stuff like running, jumping, dashing, in the context of Celeste. Now, we aren't going to be talking about polish, for example, like Coyote Time, where after you run off a ledge, you have a brief amount of time in order to jump. And while this is a very important, like, polish piece of platformers, it's not really something that we're going to be talking about. We are talking the bare bones, as in if you hold the if you hold the right button, she goes right. If you hold the left button, she goes left. If you hit up, she jumps. If you crouch, she is able to do a little dance. Now, a lot of what that's going to be tied to, specifically, especially in terms of being able to jump and descend back to the ground, is you need to add a force to the character that pushes them upwards, and then you need to be able to fall back, and that means you need to have a physics system. Now, what you could do is, if you want to, you could code your own physics system. For example, one of the things that I did for a project I had to do for school was coding a physics system of not only being able to jump, but having objects be able to interact between each other dynamically, of being able to push against objects and for them to push back into you. And this required a lot of work, especially when it came to having bullets bounce properly against objects. Especially when it was all in fixed point instead of floating point. But the good thing is that physics systems and input systems and some basic character controllers are already included in a lot of game engines of Unity and Unreal, already coming prepackaged with a lot of this stuff. So one thing to just keep in mind is please use the resources available to you, especially if you are making a game for the first time. Do not overcomplicate things for yourself of wondering about all the different edge cases that you might run into. So therefore, you should code it to all yourself to begin with. No, please don't do that. It will cause a headache and way more time spent making this for basically the same thing. Now, when you start getting into some of the details, you might realize that a pre-made system doesn't work for you, and you might need to go back and recode it, and that comes into some level of tech debt. But at least if it's good enough, use it. Now, we have the character controller and everything, and we haven't really addressed everything else that goes into making like Celeste of platforms that you're able to stand on and go through from the bottom but not from the top, blocks that you're able to dash into and are able to break, stuff that is able to regain your dash when you hit it. These are all like specific level mechanics, but you can already tell increase the amount of stuff that you're able to work on. Individually, none of these are too especially complicated, but the more that is required, the more code that you're going to have to write. So one of the first things of what increases code is just simply more mechanics. Now, that's pretty intuitive and why we're just starting there, but it's going to get a little bit more complicated as we go on. So secondly, I'm going into first-person shooters. And the example I'm going to give is Ultra Kill. So, Celeste did not have any amount of combat or stuff like that. Also, should I be checking chat? Because I have two monitors and realized I'm not doing that. Fraud is tomorrow. So big news for the Ultra Kill fandom. The stocks are going up. So Celeste doesn't really have any combat, nor really should it. That's not really a requirement. But I did say that part of the character is combat. So that is something that we're going to be talking about. Of you have a gun. You were able to shoot the gun. And the gun is the biggest thing that what makes a first-person shooter a shooter outside of the camera being directly on your head. Now, what you could do is what I said before of, tying a mouse click directly to shooting, tying the other mouse click to aiming, having it all be hard-coded down to this specific gun. But if you played Ultra Kill, you know there's different weapons. The revolver isn't the only one, and there's a bunch of different weapons. So the issue is, how do you actually support these different weapons, as well as the different bullets that you create? Now, for people who have knowledge of programming, you already probably know the answer. Make it generic. Generalize your systems. Have a general gun class, have a general bullet class, have components that are able to be attached to each of them in order to define its roles and its abilities. Hard coding things are just going to make, especially when you know that you are going to expand it, headache so much in the future. You're going to have so many headaches trying to take your system that has been hard-coded to this one specific gun or this one specific object, and then trying to split it out and making everything easier. When you are coding something that you know is going to be expanded, have it be as generic as possible going in first. Now, do not generalize everything. The over design of your game, I know that I have struggled with it, of sitting down and going, okay, this may have a chance to be expanded in the future, so therefore I'm going to spend a week making this system as generic as possible, and it's only ever used for one thing. One of the things to learn is know what needs to be generalized as well as what not to be generalized. Know what you can hard code and get away with, and know what you are going to need to be able to be spread out to be easier to work on in the future. Now, another thing is AI and bots. Celeste technically has this. Hard code it if it's a one-off. Please don't make a whole generic system. I say this as someone that has made generic systems before that were only used for one thing. But again, AI and bots. Again, this is not Gen AI. You folks already know I'm referring to bot behavior. And again, AI and bots is something that is specifically hired for as well. AI is its whole different rabbit hole in order to go down in order to programmatically make agents to be able to act within your world and be able to act against the character in a way that is fun for you while still adding a level of difficulty. Now, when someone designs, let's say, a monster that is able to attack you, like we'll just use the sentence of enemy that walks towards you and attacks you within range. This is a single sentence. But one of the very important things of AI is to know that no sentence is actually simple. When it comes to AI and bots, there are many different systems that go into them in order to make sure that they work properly. We'll start with walks towards you. How does it even know the concept of you? And this is where we get awareness systems, the ability to be able to have line of sight, to be able to recognize that you are something that it needs to target. Now, if we just say that the enemy knows you and has a constant location of you at all times, that is still an awareness system, but it's the bare bones amount of awareness. But it can work here. Additionally, walks. It needs to be able to walk towards you by pathfinding. Pathfinding has its own subsection of algorithms, and depending on what kind of pathfinding, whether you're on a grid, whether you're in a free space, whether it's 2D or 3D, the level of complication can go up dramatically. Now, the nice thing is, again, going back to the point of use the resources you have at your disposal, because pathfinding is such a common issue, don't worry about it if you don't need to. Please don't. Just use like NavMesh in Unity or the Unreal equivalent, or there's people that have made upgrades to pathfinding and have made their own different versions that you might be able to download or pay a little bit in order to take and implement. Again, in order to save yourself a certain amount of headache, you don't necessarily need to just code pathfinding all by yourself. Now, walks towards you. Enemies aren't just doing a singular thing. They can be an idle, they can be like in an aggressive mode, they can be actively attacking you. Pathfindings are solely an excuse to write a pathfinding out. We will get into that. Because we will go back to what the story that I started this presentation with. So walking towards you and the even like actively pathfinding and navigating its way towards you is a state that the bot is in. You need to make sure that it's able to be in that particular state, as well as be able to switch between states. So there's states and there's state machines. Now that's only one kind of AI like behavior models. There's behavior trees. God, what I can't think of the one that is the like the ranked choice where it has all of its different options and it chooses it based on probability. But there are different AI decision-making algorithms that you can choose between, but we're just going to say state machine because it'll also be important later. But adding all of that together, that finally gives you at least the very bare bones enemy that is able to do what is being said. But you can see all of the different systems that are put into place in order to make that even happen to begin with. So this is what I mean of breaking down a written design into its programmatic parts. So what increases code? More automation. The more things that you need to get the computer to do for you, instead of it being what the player is actively inputting in, the more complicated it's going to be. So finally, turn-based strategy. And the example I'm giving is XCOM 2. Now there's stuff like Baldur's Gate 3. But the reason I say XCOM 2 is XCOM 2 was my basis of comparison when it came down to the game that I wanted to make for Blooddelic. So turn-based strategy, like just generally giving a heads up, is a little hard. You need to be able to switch between multiple different characters, have certain pathfinding along a grid, be able to choose the exact grid position, click between characters, have all of these different actions be able to switch from that action that you've assigned to that character over to the next character, and then have the enemies be able to act. It's everything that I've said before, but way more. So you have state machines everywhere. Not like, in order to be able to have a turn, you need to have one player, like the character, do one thing, finish its action, be able to go, hey, I am done, then move on to the next character, who is then able to determine something. The program goes through, performs that action, which is a set of steps, and then finishes, and then goes on to the next one. The systems all must be generic because they are going to be interacting with each other. You are going to have characters run into different people's line of sights, and they are going to need to be able to take its awareness, be able to switch what action it's going to take. They all need to be able to interlace with each other in order to make the gameplay itself work. Enemy pathfinding is easier if you're doing grid-based, but it's way more complicated awareness and active attack patterns. Because the biggest thing is also the players are controlled by the computer as well. Your barrier to any amount of basic gameplay has just skyrocketed. Because it's not the player directly pressing keys and moving their mouse and being able to see gameplay represented directly in front of them. You now have to do all of the work in order just to have the player direct a character to move. And that requires so much setup that if you're not prepared for, like I wasn't, your game's not going to get done in time. And one of the other biggest things is that your controls have become far more abstracted. Not only with the movement is not just tied to you moving forward and backward with WASD, but a lot of actions can be just boiled down to mouse clicks. And having to be able to switch between what a mouse click means is complicated all on its own. The input machine is its own state machine. You need to be able to click on a character, be able to go into its movement mode, be able to click the grid that you want to be able to move to, have it understand that that grid click is a selection for that particular character because you've already chosen it, and then have it prevent you from being able to input anything, signaling to the character that, hey, I am now able to move, the character then performing its movement, ending there, and then it giving action back to you. Oh, no wonder if 2F for my soldier isn't getting 5% shot. You should be. You should be able to hit that 15%. So, another thing that you need to worry about is now UI. Most of the time, when you're thinking of a game, UI is something that can be handled by someone else or something that can be done later in development. But when you are choosing between options that are set on the screen or clicking between choices that are laid out in front of you, UI is a direct barrier between you and the gameplay that you want, unless you want to have a single key on the keyboard for every single action. So there is, 1, 2, 3, 4, 5, 6, and being able to swap between just based on the stuff here. But if you just want to be able to click and move, I also don't think this is XCOM 2. But when I was looking up images of XCOM 2, I think this just came up, but it's the same thing. It's a turn-based game. I actually don't know what game this is. But for you to be able to click on it and perform the action, you need to be able to see what you're doing. So what increases code? Increased player abstraction. If there is now more of a gap of not even in terms of all the rest of the mechanics, but the player being able to perform the actions that they need to, and that the actions need to be formed directly by the computer, your work has just increased a ton. But that's your job as a gameplay programmer. It's fun to code all this stuff. Not when you're on a time crunch, but it's fun to code all this stuff. So going finally back to my example of Bloodelic, here's all the ways I screwed up. It was a turn-based strategy stealth game with completely custom pathfinding that needed AI with good awareness mechanics that were able to communicate with each other. For my first game, what could possibly go wrong? I'm going to leave that be a rhetorical question. You can now see the pitfall, like all of the pitfalls that I found myself in, all of the questions that I didn't even know to ask, all of the code that I didn't know that I was going to need to write. But although Bloodelic ended up being kind of a mess, it was the game that taught me so much about how to be a gameplay programmer. So, takeaways. How long will coding actually take? I have no clue. I still don't know how long it takes. I'll pull up something and be like, yeah, this takes like a day and it takes me a week, or I'll have something that say it takes me a week and it takes me an hour. I'm still not good at this point of estimating how long code is going to take. But if there's one thing that I've taken away from like working with mentors, working with people more experienced with me, the quote that I have taken away is from my manager at Insomniac, or my former manager at Insomniac, Adele Laurie. He's now at Riot. He's very happy. Is one of the biggest things that separates programmers beginning their career and senior programmers is the ability to estimate how long a particular task will take, and that's something that can only come with experience. You will not know how long something will take until you've done it numerous times and you are able to have a ballpark range. Not only are you getting faster at it, but you know generally how long this has taken you before and how long this will probably take you again. It is something that you can really only feel out. But the most important thing when beginning is knowing at least what systems you are going to need. So you need to bridge the gap. And that's my presentation. So thank you. Questions? Chugging my water real quick. I love that GIF. I love that emote. Have a frequent heuristics when t-shirt sizing a task. Um, that's a great question. Uh, I guess it depends on what kind of task because there's so many different amounts of gameplay tasks that exist that where it's like, okay, if you're just like formatting, like if you are creating a UI button, it's knowing that you are able to very easily be able to trigger something off that. But I think it's a matter of telling what can be very easily transposed into Boolean logic and what will need a lot more support set up for it in order to work. I think that's like the first, I guess, question. Um, is it something that the computer is able to easily translate into code versus, okay, this is something that a human is good at, but a computer is not good at? Being a 2D puzzle game. So it depends on what kind of puzzle game. But one of my first thoughts would probably be controls. Um, is it like point and click? Is it stuff that you move around on your keyboard? Um, how'd you compare your experiences doing gameplay program on AAA versus indie projects? No, I think that's a good question. So when it comes to gameplay programming on my own projects or with friends or stuff like that, um, the stuff that you are tackling is far more broad. It is, I guess, like setting up, like you're switching between being a UI programmer to being an AI programmer to being a character programmer to then fixing bugs to setting up the systems. You're not only going the spectrum in terms of roles that you can have as a gameplay programmer, but also the various levels of seniority. Um, but I guess like as someone that's still, getting into the industry, I have a couple years of experience under my belt at this point. Um, those tasks are much more specific and much more directed, and especially those code bases are far bigger. Um, those code bases have far more complication than anything I have ever personally coded. And you are going into the nitty gritty where one of the important things that you need to have as a gameplay programmer is being able to read code and read it fast, of being able to parse what is going on within the particular code base, be able to get caught up to speed of how the specific logic works, and then be able to dive into it and make the changes that you need. Um, so there will be um, specific problems that you come across when it comes to debugging enemy AI behavior or debugging or adding traversal mechanics or combat mechanics, because like my current roles have gone from combat programmer, like player, traversal programmer for player, AI programmer, and then general like client support, which is consisted of like server and like user facing problems of like UI and such. So I've kind of like run the gambit of kind of putting my foot into everything that you could touch. Um, and there's more. There's definitely more. Like white tiles, but competitive white tiles. I don't think I've heard of that. Oh, it's like the piano tiles game. Okay, that that feels like there's some procedural generation trouble that you might have. But if it's puzzles, then you might just be directly designing it, so that might not be an issue. Um, Honestly, a lot of puzzle games, the biggest problem that you're going to have is actually designing the puzzles than actually programming it. Um, Honestly, I've never used t-shirt sizing tasks. I've used just like general story points, but even then, story points are just kind of ballparking. Um, a bigger triple as in sharing work with a lot of people. How much of your job is problem solving? So it depends on how many people that you're working with, and it depends on how much the ownership actually goes on you, and also how good your checkout system is. Um, Generally, if you because you're working in such a specialized space, um, and if everything is PM'd well, you should be either the only person or one of the only people working on a specific task. Um, so hopefully there's not too much of overlap, but I know I've had times where it's like, oh, there's this big thing that someone is working on that I'm going to need to wait on, uh, that they're going to need to push, that then I'll be able to add my changes later. Um, it also depends on how in progress the work is already. Are you just like fixing up and maintaining, which in that case you're probably not going to be overlapping too much, or is this kind of a collective working from the ground up? And in that case you're going to be overlapping way more. Now when it comes to AAA code bases, I have not been in the position where I am making a game from the ground up, or like you're inheriting a code base that already exists and then modifying it up for your purposes, or just like adding new things onto the large behemoth that is like the character controller. Um, uh, but normally, if you have a good amount of communication, there shouldn't be too big of an overlap. Story points, yeah, story points make no sense to me. It's just like I think it'll take this long, and it never does. Um, how important is writing documentation between AAA and indie projects? No, that is an excellent question, actually. So for writing documentation, I think for AAA, it's extremely important, especially when you are onboarding new people and for legacy code bases. I was going through and I was changing code that was last touched in like 2015. I was touching code that hadn't been changed in a decade. Um, Having and in a company, if there is any amount of turnover, you are going to lose that tribal knowledge if you don't write documentation. So you need to have people like, and this is an issue because it would be good if there were like technical writers that were able to sit down and document a bunch of the code base for parts that are not in flux actively. For someone to be able to go back and go, okay, this is everything that is there, but like a yearly rewrite is great, and having someone in order to step you through or give you just a large document that is okay, this is how our entire AI scheduling system works. These are all of the different components attached to it, because there's like 50 different ones. It's kind of crazy. AAA systems are so complex that if you don't have any documentation, you're going to give yourself a migraine, and you're going to be entirely lost. However, when it comes to indie projects, I would say it's not as important, especially because a lot of those systems are being written from the ground up, are constantly in a state of flux, and you have a much smaller team to be able to talk between. Um, uh, Now, if you were working on like a larger project where it's still at a company, then like at the end of the project, you should probably go back, especially if you have any intention of reusing that code base. But for your own personal projects, do not worry about writing documentation. That's going to change within the month. Would you say most platformers are simple games to code? Yes. I would say most platformers are easy games to code. I say they're hard games to polish. Making movement feel good is tricky, but having movement in itself is very easy. That is where the complication comes up. It is very easy to have a platformer. It's hard to have a platformer that feels good, because that comes into not only just like gameplay, but also in terms of like player forgiveness. Like I was talking with the coyote time of falling off a ledge and still giving the player a little bit of extra. Um, uh, Smooth interactions when it comes to walls and other objects, so that you don't accidentally clip. Having art and animation add to the feeling of platforming, because you will be shocked at the amount of times that you'll have a platformer and feel like this kind of feels bad, and then you add like a bit of like dynamic art, or you actually like have a player sprite, and then suddenly it's like, oh, this actually feels really good. So yeah, that would be my answer. That's honestly excellent piece of advice. If you have to ask yourself what you wrote, write a comment. If someone else has to ask you what you wrote, write a talk. That's a great piece of advice. I would recommend like commenting your code, but I cannot say that from a very official position because I'm terrible at it. Commenting your code is very good, but mainly comment your code when it is not obvious at a glance what your code is actually doing. If you are able to step through and see, okay, this is a for loop that is going through all of the different players to do X, like that is something that you can very easily read and scan through and understand what's happening. If there is some amount of complex logic that is like obfuscated through it being a method that points to another class, or some amount of like lambda functions that were passed in somewhere else, if it becomes complicated and you cannot tell what is happening and you feel like you're going to forget it within 2 weeks, write a comment both for everyone that comes after and for yourself in 2 weeks. That just came up. If you had any stressful experience with time crunch in the industry. So thankfully, not too much. So I love, like I loved my time at Insomniac as a company. Um, there was like some amount of it wasn't even required overtime. It was just like, hey, if like people were able to do this, that would be great, and we'll also compensate you time off. Um, I thankfully have not gone through the crunch trenches. Um, but I cannot say that it doesn't happen because obviously it does. Yeah, there's Insomniac Games. They're the people that made Ratchet and Clank, the Spider-Man games. They have Wolverine upcoming that I think just had their release date announced. Let me double check that. That's going to be the first game I have my name on, which I'm very, very excited about. Yes, September 15th. I think podcasts or media you listen to keep up to date on best practice standards, give them professional development advice. Honestly, no, but I should. Um, a book that I've been meaning to buy for a while is Gameplay Programming Patterns. Actually, I think I may have bought it. I just haven't, like, I think I have the digital version of it. But programming patterns is something that is very, very important. It's something that I need to get better with. because they are going to, like, patterns are very, very important for making your code smooth, accessible, not as like a mess, to be technical about it. I was saying I think they should have waited a week so you could play some Earth, Wind, and Fire music. Publishers, yes. I almost wrote a whole thing about event systems. Event systems are going to be a godsend. Event systems are so important. I didn't want to get into like specific gameplay programming patterns, but yeah. Cool. Well, thank you guys for the presentation. They're letting me give the presentation. That's what I meant. And thank you guys for listening and being here.